So I was told because I gave another talk earlier today. I was told that there's a big overlap between the audience, but I can see there are quite a few new faces, and so that's why I prepared a different slide deck for the second audience, so I don't bore the first audience who already heard what I said. There's a little bit of overlap in the content, but if you so the second one I was told that because most of the users here are already familiar, have used the DAX. Is that true? So anybody never used the DAX before? Raise your hand.
I don't touch that.
Okay. And so Power BI is a very rich product by itself, and so you can do a lot of things without the need to use DAX at all. So that's the beauty of Power BI. But my talk today is going to be focused on DAX. So it's considered the hard part of a Power BI. Every time you need to start writing programming language, it's getting hard, right? And if you have never used the DAX, just be sure that you can do a lot without using DAX at all. First about myself, I started my BI pretty early, before I even joined Microsoft. I've been with Microsoft for 15 years, and so it's been quite a while, and it's always on the BI engine team. And before that, I was on the East Coast, also worked for a BI company. It's a startup company. And they also have an in-memory BI database. And after I joined Microsoft, I first started working on the multidimensional engine team. So it's analysis services. And later on, Microsoft, in order to meet the challenges of the self-service BI providers like Tableau, like ClickView, all those new products. So Microsoft started building this new BI platform, the tabular model with in-memory column store database called the Vertipack Engine, plus a very rich semantic layer on top of it called the tabular model plus the DAX engine. So I own the DAX engine and many of the modeling features and the DirectQuery and the composite model for people who have ventured into those more advanced features of Power BI. So I own those components. So again, my talk today is going to be focused on the DAX, but in order to understand the DAX best, you need to learn some modeling. Eventually, you don't need to do it on day one of using DAX for sure. Okay, eventually you want to master DAX, you want to learn some modeling. There are some many good white papers put out there, and Marco Russo is a famous. I don't know if it's Marco Russo or somebody else that said the most distinct feature of Power BI is a model-based reporting tool. That makes it both easier and complex in different ways. All right. Okay, and so let me just directly. So I want to first assess the level of the mastery of DAX here. So I will put out some very similar DAX expressions, and I want to hear from the audience that what they do and what's the purpose of these DAX expressions, and what's the difference between them. All right, so let's say I have defined a DAX measure called distinct customers. It's simply a distinct count of a customer key column. Let's say that's a measure. And then my question is for the following three measures that are built on top of the first measure, what do they do? And what's the difference between them? Anybody want to?
The second one, the first calculate, that's going to go over your geography where it equals the United States. So it'll give you a distinct count of your customers in the United States.
Yeah, that's right. That's all three of them seem to do that thing, right? So they give you a distinct count of customers in the United States. But they are not exactly the same. So what's the difference?
The difference would be when you brought those into a visual on what you're going to see. So if you brought it into a matrix
Uh-huh.
on the values that you would see
Okay.
based
And
on what you brought in from your customer key or your whatever it is that you're looking at to see your customer key. So on one you would see the same number for all of them. One you would just see a distinct number at where you've got your filter, I think. And then the third one, the bottom one, would give you, trying to think what it, I think it's going to give you kind of that same number that you get on the second, or the first calculate, and the third one would give you all the same numbers in the column.
actually, let me ask this then. How many of you have written a DAX expression like one of the three? Okay, more than half, right? How many of you have written this second one? And the third one? Fourth one? Okay, okay, okay. And when you do them, well, why? Can you tell me why you choose one over the other? Because they seem to do some very similar things. Right?
The last one cancels out the user filters that they would have done on the report and apply United States no matter what. Whereas the filter on the country on the report, so it starts by canceling out what the user has selected.
Okay. The last
and
one.
then applies, yeah.
Okay. How about the second and the third? Do they also cancel out the user filters?
No.
Okay.
Doesn't the second one cancel out filters within the query, not outside?
Okay. So let's actually, I have a workbook which I already have the three measures created. So let's add them to the report to see how the behavior is different. So before I add them, first let's see the data. So I have a very simple model. It's a standard Microsoft like a marketing created artificial database. It's a star schema. For people who are familiar with a star schema, so basically it's a sales table and connected to product table, to customer table, to data table. So there are to geography table, to sales territory table. So I have a model. I bring a sales table, I bring customer table, product category, subcategory tables, geography table, and date table, and I connect all these tables together. All right. So the model, I hope, is self-explanatory. And I go back to a report. So I first show you the data. So before I add the other measures, let's first look at so I have a small report which I drag the product color plus the number of customers and the number of distinct customers. So it's basically for each color and how many customers bought the product of that color and how many distinct customers who bought the products of that color. So it's a very basic report, right? And now let's compare to the, let me see if the log object can work. And where's my view? I don't know if they still allow me to modify the report. Let me try it again. Okay. So let me look at the different ways. So one, distinct. So this one is no. Calculate. Okay, no, that's not the one. It's on another report. Sorry. It's on a different report. Let me bring it up. It's on this report. Yeah, okay. So I have the measures pre-built. So one is saying, okay, it's slightly different, but it's the same. Okay, so instead of calculating distinct customers, I'm calculating sum of sales amount. But the important part is the filter part, right? So this one is saying geography countries equals United States. This is one way of setting the filter on country equals US. This one saying filter all of the country where country equals United States. It's another way of doing this. And there's another way. It is a filter the geography table, comma, country column equals United States. So I have three measures that seem to do the same thing. Okay, and instead of getting distinct customers, it's getting me the sum of sales amount. Okay, so on the first report, I have two different reports. On the first report, I have a year and the sales per year. Okay, so now if I drag the measure to this to the first report, intuitively it should give me the sales in United States broken down by years, right? So that should do. Let's see if it does it or not. So drag the first one to here. It gives me a smaller number. Seems to be a subset of the grand total. So it looks like it is doing for a particular country. Let me drag this one. It's the same numbers, right? And how about this one? So all three give me the same numbers. So this does tell me that the three expressions more or less do the same thing. They are setting basically they are saying, in addition to the current year, I want to set a filter on country equals United States, so you give me the sales for that year and for the US, instead of for any country, for all the countries, which is the first column I have, right? But the problem is, the second, if I drag the same measure to a different report, one of the beauty of DAX measures is you can add it to any report, and they should almost always work, right? So let's see. In this one, instead of breaking down the sales by year, I already break sales down by countries. So I'm showing you the sales per country. I broke it down. And actually, we can even corroborate that. Oh no, I don't, it's across all the years. So you have to sum up the U.S. sales on the left side, which is broken down by year. Okay, and now if I drag the three measures to the report, so the first one, so it's getting me the U.S. sales across all the rows. That seems to be doing what it's supposed to.
So click on that so you can see that.
Okay, I'll show you the measure again. This is the measure, which is no filter around it, just the column, the geography country equals United States. It seems to be doing the right thing. Okay, depending on right. What do you mean by right? Some people call the other one right. Okay, let me try the other one. This is the other one. This time I say filter this table where country equals United States. Let me drag it over. It's producing a different result this time, right? So it's showing the sales when the current line is United States. It's showing blank for all the other rows. Actually, you don't want to say which one is right, which one is wrong, because it can be right or wrong depending on your business need. Some people prefer this one, right? They said I want to blank out the other countries instead. Okay, some people prefer it that way. Okay. And if I drag if I drag the third one, so it looks like the third one, which is filter, instead of filter a table, no, this is the third one I dragged. Instead of filtering a table, I said filter all of a column. So I said filter all of this country column, where country equals United States. So one thing we learned is here is the three different ways of writing a similar measure. They actually, even though they work in most cases, but if your report has the country column in the report, they have different behaviors. And the reason I call the first one 1, the next one 1.1, because they are equivalent. You can see they produce the same result. Okay, but the 2, the measure that with the suffix 2, is producing a different result. So this is one of the very common confusing point for people who learn DAX at the beginning. So let's go back to the slide. So as it turns out, all the DAX filters are tables. So how does the DAX? So people didn't realize that. Okay. So even though you can write the filter like in the second line, which is looks like it doesn't look like a table expression. It looks like a Boolean expression, a true or false expression, right? It looks like it will return a true or false. But internally, all DAX filters are just tables. So how does a DAX filter work? If you look at a typical DAX report, so this is one of the reports I created earlier today. So let me drag the measures in here. So it shows you the number of new customers over time who bought different products. Let me set a bunch of filters. Okay, so how does a DAX filter work? So that's the key point here. I just said all DAX filters are tables. Right? So look at this report. In this report, I created a measure called new customers. Yes, called new customers. It has a very complex DAX expression. We don't have to go into the details here. But what it does is it will return the number of new customers who, based on the current filters. And what filters I happen to have? I have a color, product color. So it will tell if I choose different color combinations, it will show me all the new customers who bought the products that is one of those colors. Or I can put a filter on the gender of the customer, which says all the new customer, all the new male, in this case, all the new male customers who bought the products and that also meet the other criteria. So the filters, in this case, I can hover over this report. This report, every data point will give me the new customer count. In this case, it's a 33. So for the year 2013, August, the month of August, there are 33 new customers who bought the products either of a blue color or of a red color, and it's a male customer. Okay? So exactly what type of a table filters I have. So if I hover over this funnel icon, it will show me all the filters currently apply to this visual. And so I have 3 tables internally, okay? And each table in this case only has a single column. So the first table has one column called color. It has 2 rows. The first row is blue. The second row is red. The second filter table is has a single column called gender, customer gender. And then it has a single row in this case, which is M, the male. And I also happen to set a product category filter is in my filter card. It's on, where do I set it? Yeah, in the filter pane here. Okay. Yes, they moved it. Yes, yeah. They recently moved it. So I have another filter. It's also a single column filter that is on the product category name column. It's a single column. And this one has 2 rows. One is clothing. The other one is components. So I have 3 filters in my so-called filter context. That is telling me that when I calculate the number of new customers, what filters I need to apply. And last but not least, the visual itself has many data points over multiple months across different years. So for every data point, there is a filter that applies to this data point. In this case, in addition to the 3 filters that are common across all the data points, this particular data point has its unique data time filter that is a year equals, we can say maybe this one is a 3-column filter, a single row 3-column. The first column is 2013, the second column, the first column is year, the second is quarter, the third column is month, and the values for each column happens to be 2013, quarter 3, August. All right. So all these filters are just tables inside the filter context. Okay, and then you will ask, what do you mean by filters are tables? So it comes down to how filters are applied in DAX. If I go back to my slide, so in this case, I have a sales table. Okay, the distinct customers is I'm scanning the sales table, and then I'm gonna apply all the filters when I scan this table. And so what do you mean by I can apply all the filters to the sales table when the filter is on the customer table? Because you create relationships in Power BI, right? That's the important part of a relationship. A relationship is all about how to flow filters from one table to another. Because you have all those relationships, and so the sales table, if you know SQL, the sales table will join with the other tables that are related to it. So it will join with the product table, the customer table, the date table, and then it will apply the filters on those other tables as well. So the result, so you can think about the way DAX works is, you have a table scan, you will join with the other tables following all the many-to-one relationship. Here the cardinality matters a lot because I need to count, I need to do a sum. I need to get the sales table, I need to join with the other tables that has filters, I need to apply the filters to them, and then but in the end I need to do a sum of this. So if it's not a many-to-one, then the cardinality of the table will change. Does it make sense? So if you have 2 tables that's a many-to-many relationship, if you do an inner join between the 2, then depending on the matching data, then both tables can get duplicated rows, because a single row on either side can match multiple rows on the other side, and then the output of the join will have replicated that single matching row multiple times. And if you try to do a sum over it, you will get a horrible result. So many Tableau users didn't know that, because Tableau only allow a single table in their model. So you have to do a join ahead of time. So we used to have a Tableau customer saying, oh, you're not doing the right thing and everything, the result doesn't match. I said, most likely you don't understand how Tableau works. Tableau, because it does a join, and that particular customer, they happen to have a many-to-many, it's not a many-to-one. So the table rows get replicated. So when you do a sum over this, you get the wrong numbers, because your cells will get replicated many times, right? Yeah. So this is one of the strengths of Power BI. So we make a multiple table join relationships easy to configure, and in the meantime, we will preserve the correctness of the result. You can do all kinds of fancy things. For example, if you don't do a sum, you do a count. If you have let's say if you have a join with a customer table, then the customer table gets replicated, right? But if you do a count on it, you can overcount the customer. But if you do a distinct count, so in Tableau you have to say, oh, I want to do distinct count, even though the original customer ID is unique, for example. Okay. So coming back to here, so the way the filters are applied is you have a table, then you follow all the many-to-one relationships, and so you join with all the tables that's related to you, and then now you can say, okay, which tables have filters on it? And then we apply the filters, as I said, it can be a single value, single row filter, or it can have a multi-row filter. It can be a single column filter table, can be multi-column filter table. If for anybody who understands SQL, it's kind of like we call it a semi-join operation. If you're not familiar with semi-join, you can think about we do an inner join with that one, but we don't output the columns from the filter table. It's kind of like an inner join without outputting any columns from the filter table. So it's called a semi-join. So basically, for each row, we try to say if there's any matching row in the filter table. If there's at least one matching row, I'll output this row. But if there's no matching row, I will throw this row away. And then for every row, I will check every filter table one by one. So the order of filters, they doesn't matter, because I apply the customer filter first, apply the product filter first. It doesn't matter, right? So all the filters will be checked one by one. So every single row is checked against all the filter tables one by one to find at least one matching row in there. And only when the row survives all the filter checks, it finally survives the filter operation, and then it will be used for the sum or distinct count or count or all the other aggregations that will happen afterwards. You have a question?
Yeah, I have a question.
Yeah, sure, yes.
So, given what you just said,
Yes.
why does the second calculate have a different result than the first calculate?
I'll explain. So I'll explain. And now so first of all is that's how the filters get applied. That's number one. Okay. And then let's look at the fact that all these filters expressions, they are spelled differently, means that they have a slightly different semantics. Okay. The first one is because every single DAX filter is a table, therefore this Boolean expression is equivalent to a table expression. It has to return a table. What table does it return? It happens to return the identical table of the bottom one. So the second expression, this expression is identical, is converted to this expression, because the bottom expression returns a table. It's a table of a single column. The column is country, and it has a single row, which is United States in this table. So this is the single row, single column filter table. But this one is different.
We're not seeing.
It's hard to tell because
You're only
these
to see
arrows
yours
don't
now.
are
Annotations.
Oh, sorry. You cannot see my cursor at all.
Yeah, we'll annotate on PowerPoint.
Does CSG have a pointer or?
Should be a pointer or something you can use on PowerPoint.
So that's very bad. Let me exit out of here. Can you see my cursor now? Okay. Okay. So we'll just do this way. Okay. So for this expression, because it does not look like a table, it actually has to be converted into a table. Which table is converted to? Converted to this one. So this one, you can say, because it says I'm filtering a single column. So the overall output of this expression returns a single column table. This column is on the country. It's a country column. Okay? And this expression, this table expression, it returns a table, the geography table. And the geography table has quite a few columns. So geography table has quite a few columns. So that DAX expression, because it doesn't specify which column. By default, that table expression will return all the columns. That's one difference. Another difference is I didn't put here, I have a all. All in DAX means when I go over this country column, I ignore any filters on the report. And then I will check myself against the United States, and then I will produce a filter table that's United States, and then this one will replace any existing filter on country column. So so that's why on the second report, when you say different countries, why we're ignoring that country? So because we're overwriting that country. We're replacing that country by my new country, which is the United States. So I'm always going to return. That's why you get the same value across all the rows in the second report. That's why. It's because I replaced that filter.
Is it kind of a redundant logic? You say, I want a filter, then you say ignore the filter. So instead, you can just do the number 2, right? Because you say you just like overwriting what you want.
Well, it's not overwriting what I want, because if you look at my report, no, this one. In my report, no, not this one. Simple filters, this one. In this report, when I drag this U.S. sales, I want to ignore the measure. But you notice that I have another measure, which is sales, which I do want the first column, this column, to honor all the countries. I simply want to compare different country sales versus U.S. sales. I want to put them next to each other. So I only want to ignore this country in this measure, but I don't want to ignore it in this measure. So it's not redundant.
No, I mean the U.S. sales 1 and U.S. sales 1.1. U.S. sales 1.1 is using the filter and all, not that one then. Which one has the filter and the all?
This one.
Oh yeah.
Yeah.
So that one is kind of a redundant logic. It's like you doing something and you override it later, which is not necessary, right? What is the difference between 1.1 and 1?
These two are identical, except the one is longer, one is shorter. That's the only difference. So this is just a syntax sugar. As I said, this one doesn't look like a table expression. It looks like a true-false expression. So since I've been repeatedly saying, since everything internally must be a table, this true-false expression is converted to this one for it to return a table. So they are identical. They have identical behavior, except that one is shorter, one is longer.
Is one more efficient in the process?
No, there's no efficiency difference at all. They are identical.
Isn't there exceptions until your filters are applied on your sheet then?
Sorry,
Between those two, between 1 and 1.1, once you add in your filters and you do your slicers, 1.1 would be different output than 1, right?
Like if you filter.
No. 1 and 2 will return different. But the 1 and 1.1 return the same. See, you look here, 1.1, 1, they return the same.
So if you were to add a filter, let's say you put a customer as a slicer in there.
I'll put a customer here. Okay, sure. I can put a slicer. I can put a customer. And I can by education level. And I can choose a graduate degree. They will still produce the same number. So because I'm only changing the country filter, I'm ignoring all other filters. And any other filter still flies through. I'm only replacing the country filter.
So,
Yeah.
So if I understood what you just said, the U.S. sales 1 and U.S. sales 1.1 are identical queries.
Yes.
Just the format of the query
It's a slightly
is
different.
succinct versus elaborate.
Yes.
U.S. sales 2 returns blank because there are no query results where the country equals Australia and equals United States.
Correct. But why? Right? That's the
Except for United States and United
Yes, that's a very good observation. Okay. But why is that, right? Because does it mean that when I use the filter geography, it does not replace the United States? It still override. So by default, the DAX filters always overwrite the filters coming from the visuals from outside. Okay, so this expression is no exception. It also overwrites, but there's one important difference, because here the geography in this expression has no all around it.
Right.
All means ignore filters from the surrounding, in the filter content, from the surrounding. Without all, it means first filter geography itself by any filters that are applicable, because the only filter that are on geography table is my country. So that's why this expression produces no difference here. There's no filter on country or anywhere in geography. And this filter doesn't apply to geography either, so it does not matter, okay? But in this table, each row has a different country filter. This country filter will filter that geography table. So when I go back to this measure, because it does not, the 2, because it doesn't have the all around the geography, so the geography is first filtered by the current country. So in the case of Australia, only the Australia is left, row is left. And then it will further try to apply its own filter, United States, which produce an empty result. So the net result of this filter will be an empty for the Australia. And when this empty filter is applied to the sales table, you get an empty result. That's why you get all these blank rows across the table except for United States. Because United States and the United States, they actually, you have one row survive. Actually multiple rows, because the geography is at the city level, not at the country level. So you have a multiple rows. Okay. So go back to my slide. So this is one of the most common confusing point. Okay, and simply because many people learned that the filter is supposed to start with a filter function, so they don't like this syntax because there's no filter in there. So some people use this syntax simply because this syntax is shorter than this syntax, obviously, right? So people don't like to type this one. So even though we offered them a shorter version, some people don't discover this one, or they don't like it because it doesn't have a name filter in it. So they end up typing this one, the shorter. But this one, as I said, it has a side effects, has two side effects. One is the filter itself is being filtered. You didn't have an all around it. And the second is the filter has many columns. So can potentially be a performance issue too, as well.
Oh, so that's what people say, you don't use calculate and filter together. Not when in the case of all, but just like calculate and filter is not necessary.
You can use them together, but when you use them, please use all, and to minimize the side effect. Okay, so you want to say all of a particular column. You always want to explicitly list the columns you are changing. That's just the rule of thumb. Okay. So to minimize the side effect, put all means the filter itself is not being affected, and use a single column means that when it overrides things, it only overrides the filter on this one column. Especially for many people who have a single table model, then it can get very hairy if you don't use if you don't do it. Okay. So, by the way, there is a need. So for people to say, what if I do want this? This is exactly what I want, right? I do want to show only USA has a value, and the other values I want blank. Isn't that means that's a great use of the feature that I can use? So you can achieve that, and also with minimal side effect. That is, you can still use this syntax. So I'll copy and paste it. I do a new measure. I'll call it 2.1 because I want to produce the same result as 2, which is a blank for all the countries except for USA. Okay, and then I will keep something called keep filters. I put this around it, and then when I drag this one to the report, it produced the same result. It produced the same result. But this is a nicer expression because it's a single column filter. This produces a single column filter. So it typically, just like as a developer, I'm having an engineer all my life. When you write code, you always you want to, in order to write a very complex code, for every piece of code to write, you want to have the minimal side effect. So including both itself being affected and how it impacts the rest of the system. So unless you know for sure you understand what you're doing, always try the minimal code. Minimal doesn't mean the shortest code. It means the minimal impact code. Right? That's just like a good hygiene when you write a complex system. Right? And so what does a keep filter mean? It means don't override. It literally means don't override. So if I already have a filter on country, keep it. And then add another filter. So that means in the filter context, I can have as many filters on the country columns as I want. I can add 20, okay? And the net result is, since they are all applied one by one, so we call them intersection semantics. It means the row has to survive all of them, which is the intersection of all those tables, and for the final result to have a non-blank value. Does it make sense?
So the one that's simply calculate and not all, all geography, it literally, the engine always translates it into the second one, right? There's no performance difference.
The syntax sugar, there's no performance.
The one looks Boolean,
yes.
it's just, it's always going to go and do that all, and then the...
I have seen people who misunderstood that, who said there's a performance difference there. The reason why we did it that way is because the shorter version performs better than the filter version. That's not true. It's strictly for you guys to type less characters.
Yeah, so I've noticed the restrictions on that sort of format and way of expressing it, they used to be pretty strict. It used to be a simple Boolean test, and it seems to have become a little less strict over the years.
Actually, it's not more restricted, but it's, in my opinion, too restrictive in some common usage cases. For example, if you want to say, instead of a country equals USA, you want to say country of the currently selected value in another slicer, which is not happen to be this slicer. So you have to use a DAX expression to extract that value over. Then we will say, no, sorry, you have to use the full version. You're not allowed to use the abridged version. So this abridged version only works typically on simple things like a column equals a static value type of thing, or a column greater than a static value, or a combination of this using and or operators, only working in the simple cases. If you want to go beyond the simple cases where the filter values has to use some expression to calculate, then we will say you have to go back to the full version. Yeah. So there's some, yes, that's a good point. There are limitations in this simple version. Yes. Okay. Any other questions? What?
Can you click at US sales too one more time?
Click at US sales 2 one more time. Right here.
Okay. So you're saying use the keep filter instead of filter, or keep
Use keep filter is better than this one, because this one, as I said, first, the filter itself is being filtered. Second, the filter returns many columns, not just a single country column. Okay? But this one, the keep filter one, the filter itself is not being filtered. So there's less work to be done inside the engine. Right? Second is it only adds a single column filter to the filter context. Therefore, it always have a minimal impact. That's why I said minimal impact. Because in more complex scenarios, you have the filter context that has like multi-columns. So when you override one of them, what's surviving, the logic becomes quite complex. And if you are not very careful, so if you don't want to get yourself into like scratch your head, like why do I get this result? Always write like a minimal impact code. Just get into a good habit. It's a discipline thing. Okay, keep a good hygiene in the code. Okay, so let's move to. the next one, the common user issues. Okay, so let's look at this expression. Again, this is I have two measures. Okay, the first measure is called the current date. What it does is it's basically return the currently selected date. It just return a date. There's a date column, and then there can be any number of filters on your report. And this expression, the max of the date or min max doesn't matter because I'm assuming there's only a single date, okay, being selected. So min or max of single date is the same date. But just in case you select multiple dates, I still produce some results back. So that's why I use a max. So it works if you accidentally put on your filters just like instead of filtering down to a single date, you filter down to like 5 dates. So I will still produce a meaningful result. So I use a max to pick the currently selected date on your report, and then I define another measure. We have a Y2D function, but just for illustration purpose, I'm just defining my own calculation to say I want to calculate the total sales from the beginning of the year to the currently selected date. So it's a year-to-date calculation. Right? So you get to pick arbitrary date on your calendar slicer, and then I will show you that the year-to-date sales up to that date. So the way I do that is I said I want to calculate total sales. I have another measure that will return total sales. But then I said I want the filter to be all of date. I'm doing my good single column all of date trick here. I said the year. So I started a new table scan. The filter function started a new table scan. I say I'm scanning all the dates in the data table. For each date, I want to say if the year is the same year as the currently selected one. So see, I'm invoking the measure current date here, saying I want to get the current date and I want to get a year of it. I want to make sure that in my table scan, this row, if the year is in the same year, and the date is less than or equal to the currently selected one, then I want to keep that date. So eventually, it will give me all the days in the data table from the beginning of the year to the currently selected date. And then this new filter will override the existing filter. That's important because most likely, let's say today is April 24th. So on your report, your filter says April 24th. So I want to change that filter from January 1st all the way to April 24th. So this way, when I apply to my sales table to calculate the sales, I will get all the sales from beginning of the year all the way to today. So that's how year-to-date works, right? Year-to-date works by changing the filter from today, April 24th, to a list of dates. So that's why filters are all tables from January 1st all the way to April 24th. So I did that. So when I wrote that, many people do that. No, this is the wrong report. So here, I have a small report. And the good thing about the year-to-date is it works at a different granularity. So in my case, I'm currently showing you a small report where you have a year column, a month column, a total sales. And then if I drag a year-to-date, here, I should get the running total from the beginning of the year to the current row, right? So that's what I want to achieve. So this is the expression in my slide. So I have defined a measure, current date, which is getting the last date of the current selection. And then I use the Y2D sales 1. That is, I'm reusing the measure current date in my filter. So I'm saying I'm trying to produce all the dates that has the same year but less than or equal to the current date. Okay, current selection. So I add it to my report. This is not what I want, I'm pretty sure, right? So I'm obviously not getting a year to date here, right? Why?
Oh,
Yeah, the current date is using the max date of all date.
yeah.
Because you've already taken off the filter.
When you
What do you mean? I already take off.
Well, so the all date is taking off all the filter, or the filter that was on date. And so the date table you're looking at contains all of the dates, and the current date is the max of all the dates.
Okay, it's along that line, but that's not exactly what happens.
Something
Yeah,
like
that's,
that.
You're
that's
checking the year, aren't you?
what?
You're checking the year, aren't you?
I'm checking the year here. I'm sorry.
Context transition.
What's the max date of the table?
So here, I'm checking the year.
Yeah, the
year,
year is
the
the
year.
same. Yeah.
I'm saying the year has to match the year. Yes, I do. I'm checking. But
What's the last value of the table?
I believe I turned off total. So I turned off grand total. So I only have like an individual month's value. So what's wrong? What's wrong with this expression? It's obviously not getting me what I want.
So when we look at all, right, it's saying ignore any filters,
Yes.
right? Each row has a year and a month.
Yeah.
And that row has a filter applied to it for the year and month. But in this expression, we're saying look at all. Ignore the year and month on this row.
But
What is the very max of the date?
Yeah. But shouldn't I narrow it back down to the current year and?
Well, there are
Because it's a single query that you're making, not multiple queries, right? The results are a single query.
Okay.
And so when you say max date, it's looking at your.
Oh no. Okay. No, even though it's a single query, one of the beauty of DAX is internally this is not how it works. But from when you write a DAX measures, you don't need to worry about a single query. You can literally say for this value, how it's being calculated. Completely ignore what happens to the rest of the values. So DAX, literally, that's the beauty of DAX, actually. The conceptual model is very, very simple. That expression is evaluated exactly here, based on the exact filter here, which is year 2005, month January. The fact that there are other months is irrelevant. Each measure, the measure expression is evaluated per cell. Conceptually, okay? For performance reason, that's not how we do it. Otherwise, it will be taking forever for most of the business report. But conceptual model is this, all right? You don't have to worry about the presence of other cells in most basic measures. So when I evaluated that expression, I'm literally only looking at this value, year 2005 and the month January.
But then don't you apply the filter to date and say bring back all dates?
And the all days, ignore it, right? So all days, I'm scanning the all table again, the date table again. But I do have a current date, which is the last day of January 2005. My current date should be that. At least that's what I want it to be, right? And then I should narrow the full table back down to the current year again.
The max date is always the last date of the. It doesn't stop on that context there. It's going at the entire table, so it takes every time it's computed.
Okay. Have anyone has heard of the like a row context, filter context, the conversion from one to another? That's one of the difficult part of DAX. Okay, so this is a good example to tell you what happens. So in the end, how does a DAX measure work? DAX measure, the reason DAX measure works is because every time you invoke a DAX measure, it will get re-evaluated in that context, right? So that's why DAX measure is so dynamic. You can drag it into any report. As I said, each cell is producing a different value. It's being re-evaluated for every single cell. Here, I have an iteration function. Therefore, I'm going row by row. And for each row, I'm evaluating this expression. This expression has a measure in here. So the measure is being re-evaluated per row.
Per row of the inner table. Right?
Yes, per row. Okay. So that's a. First of all, there's a performance consequence. You immediately realize that that's not what you expected, right? So you are expected the current data to be from my current report, not inside this iteration function. We're not supposed to evaluate it for each row. So but performance aside, let's assume we can optimize it that way. The real reason is the current data here, because the measure always convert the current row into a filter. That's called the row context to filter context transition. That's a very abstract concept. Just remember, from the measure's perspective, there's no row context. So if I have an iteration function, the current iteration row become a filter. So from the measure perspective, all rows immediately become filters. Right? So because of that, this measure here being evaluated is being filtered by this row, which is whatever the date happens to be on the iteration. So think about this. I have my iteration is January 1st. Okay? So my current date, instead of being the outside current date, becomes January 1st, because I'm picking up the inner row, and because the inner row it also happens to override the outside one, right? Because by default the DAX override and the outside. So every time you have a new filter, it will look at, should I replace old filter? The default behavior is yes, unless you put a keep filter, which you don't see any keep filters here. So the default behavior is every time a new filter comes into play, any old filter will get replaced. A conflicting filter will get replaced, right? So because of that, the filter becomes January 1st. So my current my current date becomes January 1st. All right? And then because it's January 1st, therefore the condition always match. So basically the current date is always equal to the current row in the current iteration. Therefore this table, this entire filter function, the condition is always true. Therefore in the end the entire data table is returned. It's as if there's no filter on data table. That's why you get a grand total. All right. So the key lesson, the key takeaway is don't use measures inside the iteration function unless you know that's what you want. All right? Sometimes you do want the measures, but you have to be conscious about writing measures inside the iteration functions. That's the major takeaway of this second slide. So how do you do that? The way you do it is you should pick up the measure value, the current selection, outside the iteration. The way you do it is using the DAX variable. The variable equals the measure. It will pick up the measure value before I even start the iteration. This way, the current date is the desirable one instead of the wrong one. All right. So if I try the second one, so I basically here, I basically save the current date into a variable before I start the iteration, and then inside the iteration, I'm using the variable instead of using a measure. And the variable is always evaluated at the place it's declared. Therefore, I hate this editor. So if I drag this one, I have to get rid of the first one because it has values everywhere. Now you are getting a running total, right? Well, it's easier to see it if I apply some conditional formatting to this one. So you can say the value keep increasing, and then at the January it go back down and keep increasing, go back down, keep increasing, right? So this is the correct year-to-date calculation. Right? But the purpose today is not the year-to-date calculation because there's a dedicated function for it, but it's to show you that when you use a measure inside an iteration function, you have to be really conscious about it. Any other questions?
Just a comment. We've heard that the Italians, upon releasing their updated version of mastering DAX, immediately decided they were going to have to rewrite the entire book because of variables.
Yeah. But variable was when you say I actually helped the Power BI succeed. I actually personally make two important contributions. One of them is variables, because I'm an engineer manager. According to the Microsoft tradition, it's the program manager's job to decide what the features goes in, and it's engineer's manager's job to make sure the feature is implemented according to the spec and those kind of things. But when I said we should put the variables into measures, all the PMs were against it. They said, no, the DAX is too complex. Okay? Let's stop adding features to DAX. People are complaining DAX is too complex. I said, let's put the variable in. So I have to trick the PM, say, okay, I'll just use as like a ramp-up program, training project for my new hires.
Is that why when you type in ver, it doesn't pop up?
No, that's because the IntelliSense it's hard to do. The IntelliSense is mostly function-based, so it's hard for them to do a keyword-based IntelliSense. That's a separate issue. But yes, after we actually put in, so because the thing is that we have been programmers. I've been programmer, so programmer knows that variables will be a very helpful thing, especially that when you help you to break things down into multiple steps. There are so many other benefits that's not even in the original the design purpose of a variable. Like this kind of things was not even the original purpose, right? Okay. And another thing is we put in so much performance improvement ahead of time that when Power BI first came out, it was a success right out of the gate, more or less. Okay, do you know initial Power BI has so many limitations? But one of the biggest stupid behavior of original Power BI is if you create, let's say, 3 pages, a report of 3 pages. Each page you have 5 visuals. Let's say so. Okay, and then you decide to go to page 3, move 1 visual from upper left corner to the lower right corner. Okay, let's assume that's the only thing you do. Power BI will send 15 queries for that operation. 15 queries. Basically, at the beginning for the first year, I believe, no, for all the way until maybe a few months after Power BI GA'd, and G8, every time you do anything in the report, all the queries will be reset. Okay, every single, whether you can see the page or not, whether it's actually data changing operation where you are just like resizing a visual, where you want to resort, those kind of stupid things, every single visual's queries will be reset to the DAX engine. So the fact that the DAX can answer it's basically a stress test of DAX engine. And so the fact that the performance was still okay, even the early days of Power BI, is really because we're putting a lot of performance effort the year ahead. Okay, next. Okay, so let's say I have a measure called the total sales, okay? And I come to my report. And in my report, let's say I have a report. I added 2 columns to a report. One is the full name of customer. So it's a list of customer names. And then the other one is the different sizes of the product. So I just want to say the total sales of customers in different for different sizes of the product. So when I do that, if I drag the report to it, sales. So if I simply write sum of sales amount, it's the most basic DAX measure, right? When I add it to my report, I did get what I want, right? So I'm showing you the sales for different customer, for individual customers, for different when they bought a different sized product. Okay, so again, this is a fake demo, but in many reports, there's a business requirement. You cannot show me blank in my report. You have to replace blank by zeros. Okay, you have to display this as a 0, right? It's a pretty common request in some of the reports, right? In some of the businesses. Okay, unfortunately, this first of all, you guys need to vote. Go to ideas, vote, say display blank as a 0. This is a display feature, not a DAX feature. Okay, number one. Okay, and this is the second reason why the DAX come to the rescue of Power BI. When Power BI first came out, there are so many limitations in the front end because the AS engine, which is the powering DAX and the Vertipack engine, was developed years ahead of the UI. So by the time the new UI started the design, the AS engine is already pretty mature. Why was AS engine mature? Where was the AS engine used? Excel, yeah. Yeah, Excel Power Pivot, right? So how many people use Power Pivot? Okay, yeah, about half, slightly more. So yeah, so the Power Pivot came before Power BI. And as a part of that effort, we get to put in a lot of the core foundational features of DAX and the tabular model and all those kind of things into that engine. And also, lucky for Microsoft, Power Pivot didn't sell very well in the first few years. I already explained to the previous audience, the main reason is it's a part of Excel, and no company, and Excel is never sold alone. It's always a part, for any major businesses, it's always a part of Microsoft Office suite. And nobody is going to upgrade their entire company's Office suite because they want a Power Pivot, right? For that reason alone, Power Pivot has very little usage.
Guy calling, he says he wants to order Power Pivot.
And for that reason alone, the DAX team has the time to actually perfect the engine itself. So by the time Power BI came to the world stage, the AS engine is already mature enough to provide the desirable functionality and the performance and all those kind of things.
Unfortunately, for those of us who were using Power Pivot, we weren't advanced enough in our own knowledge to know what was missing or what wasn't working.
Yeah.
And okay, so how do I do this, right? So there are many ways to do this, and so here are the two common ways. One is people say, if is blank, total sales 0, else total sales. This is one common way of doing it, right? Converting that to a 0. Some other people know a neater trick, which is total sales plus 0, because blank plus 0 returns 0 instead of blank. Therefore, you are converting all the blanks to 0. So those are the two very common tricks to convert blanks to 0. So this is because, again, we are missing a UI feature. All right? The UI feature is to basically the formatting, right? It's how do you want to display a value? You want to display a negative number with parentheses, all those kind of things. These are all formatting features. They are not a data feature. You are not supposed to change the data. You are only changing how you display the data. DAX is supposed to return data to you, not to return the formatting of the data.
You didn't have to do that in Power Pivot, though, right? I mean, you could go in.
Yeah, Power Pivot is using the old format string, which has the option of formatting blank, but the Power BI today does not have that option.
So they forgot to bring that over.
It's not forget. It's because when they start, they are using the Power Pivot was dated in the AS engine, which is in the old time. That's before .NET, and before that, so we use the OLEDB's format string. That has the extra thing. And the Power BI, when Power BI start development, is the .NET is all the rage. So they are using .NET equivalent format string, which doesn't have that option. There's some historical reason, but still we are the BI product. We should add it. This is a very BI centric feature, right? Display blanks. How do you display blanks? So we go back to the report. So I can do it. So now they all becomes 0, right? Okay. And but there is a problem with no, there's no problem. Okay, there is a potential issue with this measure, all right? Because now all blanks become 0, right? Right? Do you know that all the BI report has a hidden filter? That hidden filter is if a particular row in the entire report they are all blanks, then I don't show that row. All right? So that means if I go here, add this one, and if instead of using the let's say the product size, I use a different column from the product table. So instead of using class, it's not size, sorry. If I use, let's say, the model name into the report, then it's a very sparse matrix, right? So now I'm breaking products into very smaller categories, and for different models, and for a particular customer, the chances are buying like one of the model is low, so you have a very sparse matrix. But if you show them as a 0, no, it's up there. You can tell it's taking a while to calculate, okay? And I have a very small database. If you have a really multi-million row database, it will take a really long while. Why? Because the product and the customer, unless they come from the same table, if they are coming from different tables, then they can form a cross-join, right? So in theory, any customer can buy any product. So if you have a million customer and a million product, the combination is a million times a million. That's 1,000 billion. That's a lot. And if you return a 0 for all those combinations, because 0 is no longer filtered out, but a blank will be, the vast majority of the customers will only buy a small number of products. So when you return blank, you don't have this issue. When you turn your measure into a dense measure, for good or for bad, you have to be watching out for large cross joins. You just have to be careful.
So is it wonderful, for example, I want to see the conversion rate. If you turn the blank into 0, does it, like, for example, this customer only they go to your website one time and they bought it. Mm-hmm. But like, since you're putting like 5 products there and you're gonna put like, there is no record for this customer at all, but I don't want to show blank, I want to put yellow on it. That's that gonna change your number as well?
Again, today the only way for you to show a 0 there is by adding 0 to the actual measure. That's the only way. There's no show me as 0. There's no option for you to do that. So you either have to go to change your DAX measure to convert that DAX measure to 0. That's a data change, because DAX measure will return different data. Or you just have to show blank. You don't have an option of having DAX return blank, have a visual show the 0. That's why I say you have to go to vote for this feature, okay? Have a DAX return blank and have the visual have an option to format the blank as 0. Okay. Okay, any other questions? Okay, so another very common case is year-over-year growth. And
so what's your solution to that then?
So vote for the feature. Really, because this is really not a DAX feature, right? So there's nothing backing down from the DAX side. It's really a formatting feature, right?
So you're saying filter out the zeros, don't show.
Yeah, just filter out the rows that don't have zeros.
But didn't you have to calculate everything to say?
Yeah. You can write a more complex DAX measure. Yeah, okay.
Filter after the fact. So there's still a performance hit.
Yeah, you just have
There'll be a performance hit because you have to calculate the zero first.
You can add a if around your DAX measure. You can make your DAX measure more complex. So you have the dense measure inside, and then outside you wrap it in a if. You said if only when the measure has a value, you return the inner one. You have to do something. You have to wrap around it. But in any case, fundamentally, as I said, this really is not even a hard visualization feature. It's just people don't know that this should be a formatting feature. So spreading the information.
So would this actually change, like, if we try to do an average, or like you have 500 customers on there, but only 30 of them purchase things? How many? Will this change an average of how many customers?
It will not. Well, 0 will not.
Yeah,
it will, because the count.
Distinct count.
Yeah. But even sum, you can say, okay, it does not change the sum if you do a sum on top of this, but it will change the performance because we're summing a lot more rows. But again, not only the visual is throwing away those blank rows, even the internal aggregation functions will throw away blank values automatically. But the 0, again, is not thrown away. So the internal will do a lot of useless work to add zeros up. And depending on the size of your data, can become a performance bottleneck.
But the nodes calculation.
For average, it may affect because now it's the count, the denominator becomes bigger because 0 is counted, is not skipped, right? Blank is skipped.
But if you add null plus 0, you'll get 0, not null.
Correct. So another very common dense example, people didn't even realize, because of this one, people consciously, I say, I want to convert blank to 0. But sometimes people subconsciously didn't know that. So this is the other one, which is a year-over-year growth. And here, so people said the year-over-year should really be the current year minus the previous year divided by the previous year. So they want to do this. But some people are good at math. They say, okay, instead of calculating the current year twice, and last year twice, I can just use the current year divided by last year minus 1, right? This way, I don't have to calculate the last year twice, both in the numerator and in the denominator, right? This is very smart, but unfortunately, it produces a dense measure accidentally, right? Because why? Is because blank minus 1 is minus 1. Okay, so not only to produce a dense measure, most likely it doesn't even return the values you want, because what you want is when it's a blank, you just want to return blank no matter what. You don't want to return negative 100. It doesn't make any sense, right? And so this one is this is the dense way, which is some people try to optimize it for it. So they drag it into the report. And first of all, it takes a while because it's accidental dense measure. And it produces a whole bunch of useless negative 100% and the infinity, and you get very scared. And, but in this case, if you simply don't try to be so frugal and just replicate the measure up and down the numerator and the denominator, which is the original math formula, DAX happen to know that anything divided by null is null, those type of things. And then you can just add it here, and it will be faster, but it still takes a while. And because, yeah, it will still take a while.
But you will create another measure that would take my current year.
Yes, that's the right one. That's the next one I'm going to talk about. Because here we are still evaluating last year twice. So that's the next thing I'm going to talk about. Where is it? Yeah. So that you have so you anticipate what I'm going to talk about, right? So you know,
just do it.
So every time you have a measure similar to the measure in the previous slide where I said in the iteration. So basically, every time you write a DAX measure name inside the expression, it is where it's going to get evaluated. If it's in a for loop, it will be evaluated in that iteration for loop. If it's showing up multiple times, it will be evaluated multiple times. So no matter how many times you want, you put it in the measure. So on a larger enterprise scale model, we have seen a user that I believe it's just this one. It's actually just this one, the year over year. And he changed the, so he said, okay, instead of calculating the last year twice, let me use the DAX variable to remember the last year value, and then I will, no, they are not using this. It's a slightly different. They have to put this around the if. They said if the last year or something, and then it's this year minus last year, something like that, okay? So they just use the last year twice in an if statement. And then, so they said, okay, now I understand that every time you put a measure name somewhere, it's getting evaluated. So if there are like two instances of the measure name, so I will be evaluated twice. And so if I evaluate it twice, one of the tricks is I can use a DAX variable to remember this value, and then use the variable in the rest of the expression. So this is how we do it. So instead of, so we said, okay, we only need one variable, but just for like a readability, I just use two variables. I have a current year variable that invoke the current year measure. I have a last year variable that invoke the last year measure. And then I'm in my divide function, I'm using variables only. I'm basically say current year minus last year divided by last year.
So if I created another measure that just took my current year minus my last year to get a change, and then I put divide function, I said change divided by last year.
Then you're out of luck because they're in different places. You can't put them into a one variable.
No, that would be my measure. My measure now, my percent change or year over year percent change would just be my change from this year minus last year. Yeah. So that's one measure. Yeah. Divided by my last year.
Yeah. Then the last year will be evaluated twice in different measures.
I see what you're saying.
Yeah.
Okay. Okay. That makes sense. Okay.
And so now if I add it here, the performance will slightly be better. Fundamentally, this is a very large table because we have a lot of, we're going down the individual customer by customer names.
What is the performance increase using this method?
Okay, for that particular user, guess what's the performance? He just changed it from two.
Well, I would guess 50% increase.
Okay, yeah, you would guess all right. So he said the original performance is like 2 minutes. After I changed it, it becomes like 8 seconds.
Wow.
Yes. Because his measures are complex measures. So it's a so when you have a complex measures, which means it's a measure that invoke like two other measures, that each measure invoke three other measures. So each measure ended up invoking maybe like maybe like a 50 or even 100 other measures. So people write a really complex calculations in DAX, and so. When you go down to those individual measures, because they put the measures in the condition, the if condition is actually introduce some context change, because we have to do strict evaluation, right? So even though the same measure show up in the if condition and inside one of the branches, the DAX engine doesn't know. So it's no longer knowing, oh, this are the same value. DAX engine doesn't even know. DAX engine says the outside one is in its context. The inside one is in the context where that condition is true or false. So it actually greatly complex the context. So yeah, that guy is like the question is how come like 10 times faster instead of like only twice? Everybody would expect it's only twice, right? It's because the position of the measure also matters in that particular case, and the complexity of that measure. Okay.
So this is a slightly different topic. When, because variables are so significant, when they introduced quick measures, they started using Treatas. I mean, you see Treatas a lot if you ever look at the quick measures. And my assumption is that it's saying, I don't know that the model is well built. I don't know that there are good relationships, etc. But independent of that, do you see Treatas as a really important function?
Absolutely.
It is.
People said the variable is the best for DAX, but variable is the best invention since the sliced bread. And then they said the Treatas is the new one, replace the variable. I wouldn't go that far, but the Treatas is is very important. Do people know what Treatas does?
You only see in
Sure.
DAX video?
Yes, there you go.
Okay, so let me show you an example of Treatas, so for the benefit of everyone. Okay, so let's say in this model today, I have a sales table, right? So let's assume I have a really, really large sales table, okay? But I want to create a so let's say I want to bring in a new sales table that is at a higher granularity, so much less rows. So if you look at my sales table today, it's pretty big, right? So so I can say, okay, let's say let's say for demonstration's sake, I want to produce another sales table, sales 2. Where's that coming from? So now you know where I originally came from. So I want to say this time I want to let's say my report will only report on, let's say, year at the year level. And for the customer, I'm only care about the different gender. And for the product, I only care about different color. And instead of looking at all things, I only care about the order quantity. Okay, so you can tell it's a much smaller table, much smaller. Okay, it's nice to report. Okay? So let's say I have 2 sales tables. My original sales much larger table, and a sales 2, which is at higher granularity, therefore perform much faster. And if my report, if it's sufficient for my report, I can do it. But I only have the same set of dimensions, right? So how do I make sure that the filters on my dimensions can float to this second sales table, right? So there are different ways to do it. I'm just showing one way using Treatas. So this is one of the purpose of Treatas. So first of all, is you notice that this is a new table. I didn't create any relationship to anybody, right? I do have the product table and the other tables, but this particular table only have the year column, the gender column, and the color column. It doesn't have all the other columns in the data table or the product table or the custom table. It also only has a single order quantity from the sales table. It doesn't have the sales amount or tax amount, or it doesn't have the extra things. Let's say I have a smaller, much more efficient sales table that can produce some quick report. Right? But sometimes I want it to filter by other things. So what I can do is I can say, in this new sales table, I create a measure. Okay, okay. So I can say the total quantity is the sum of the quantity okay, and then, but if I go to a report, I show my total quantity in a filter card, and please don't show me no, not this one. It's not a data label. So if I drag the product color here, oh no, I cannot drag it. I have to create a different chart. Delete this one. I created this chart. I say product color, and then I drag the order quantity, total quantity here, and you can tell it's not being filtered. Because there's no relationship. Oh, I logged. Oh, that's what the logs object does. It doesn't do anything useful. Okay, so although I do have a filter, the best news. In the next few months, one of the biggest feature in Power BI history will come out. Guess what is that? The default font size will change to 12. The label size. No. It's already 12. It's already 12. Why is it so small? It doesn't look 12 to me. Really, it's already 11. Okay, doesn't matter. Okay, so let's say so how do I make my report useful, right? I create a nice, fast table, much smaller, but it cannot pick up any filter. So one of the ways to do it is you can use this. Calculate. So I say Treatas values. So I say I have the product color, right? So I say color. So I say the product color, I'll treat it as my sales 2 color. And what else? I have the gender, right? Gender. The customer gender will become my sales 2 gender. And then lastly, Treatas. So Treatas literally saying, change this filter to make it behave like another one. Okay, that's literally what it does. So it's very cool. And what's the last one we have? So we have a year, right? The date year become my sales 2 year. So this is, again, this cannot perform very well because there's no materialized relation, right? Treatas is a DAX function. That means that this filter manipulation, those kind of things happens in the DAX engine first. That is definitely not as efficient as when you have a materialized relationship, which, okay? But on the other hand, since I create a small table, it tends to be okay. Right? The fact that I have a small table, therefore the list of values cannot be that many to begin with. Okay? So, year. Okay, so I changed the measure. Yes, it works. Not only it works on the direct column, if I pick another filter, let's say I pick the filter on, let's say by different size. It also works, right? So the filters from the 3 tables will flow now to my new small table. You have a much faster, snappy performance, and you have a single set of slicers can control measures from both the fast table and the slow table, depending on what you want.
So why would you do that instead of actually doing the relation?
You could do relation, by the way. You could, okay? Especially this will be a many-to-many relationship because the color is no longer a unique key in. None of these 3 columns are unique columns in either of the tables now, right? So they become a many-to-many relationship. So you could do that, yes. But then when you have because then well, in this particular case, it's very simple because you only want a single direction filter. So you could create a relationship. But in my case, I cannot do it in this particular case because if you want to do that, this is a small table. I have to create it using DAX on the fly because I don't have time to import data. Then you have to import data because right now there's a circular dependency. When I create a DAX calculated table, if I try to create a relationship back to the original column, I create a circular dependency. So I'm blocked in my demo scenario. But in real world scenario, you actually just import a pre-aggregated data. I have two different tables. So you have a fast table, small table. Then you can create the relationship directly. It will be many-to-many relationship. That's why many-to-many relationships are important, because it's a higher granular. Basically, it's no longer unique. None of the columns is unique. Of course. Yeah.
Is it a can of worms to say more about many-to-many relationships?
I know Marco Russo said that. So the many-to-many relationship is evil. Okay, let me put it this way. That the Power BI is useful exactly because you don't need to attend Marco Russo's seminar first. You can start using Power. You have no idea. One of the reasons people like Power BI compared to Tableau, Power BI, I agree, visualization is very limited compared to ease of use in certain aspects is very limited compared to Tableau. But other than the fact that the Power BI is super cheap, and there's another important reason. You get to throw any number of tables into Power BI, and you somehow connect them together, and in many cases, it just works. It just works. And in order for that uneducated scenario to work, you have to turn on many-to-many relationships or bidirectional cross-filtering. Otherwise, you will not produce the result. But go to enterprise, yes, you have to do the Marco Russo the right thing. So the good thing about Power BI is you can, at one extreme, you can do really random things, and as long as you don't go crazy. And typically, you cannot go crazy when you are beginning and do the small data volume thing, right? So you're fine. Okay, you can do a lot of things. You can throw. I very frequently see models with like 50, 60, even 100 tables. It's like because people most people, if you are trained BI professional, you know, only import the tables you need, only include the columns you need for the report, right? But for average people, they don't know. So what's the easiest solution? Everything, right? Include everything in the Power BI. And so yeah. So the common and one end of the spectrum is you have a super big complex models, complex in terms of the number of tables, those kind of things. But for those people, it works. Why prevent them from using it, right? Why scolding them for creating BI, those kind of things? On the other hand, if you are creating a real, like a IT certified data set, you better do the like a star schema and the proper relationship. Only use bidirectional cross-filtering very judiciously, and you want to do the right thing. You want to behave like a professional, right?
Just one thing about that Treatas then, what I take away from what you said is it really enables us more easily to do summary tables with our models. I mean, if nothing else.
No. We have an aggregation.
I know we have aggregation.
Yeah, you can try that one. You can try that one. But if that one doesn't work, there are some limitations there. So this is always your manual way of doing aggregations. Okay. Yes.
So, can I ask a question? So the summarized columns function only updates during our data refresh. Is that correct? It probably is, because you're...
Well, what do you mean by it? A function is just a function depending on where it is used. A function...
Well, the summarized column that you use...
Oh, that calculated table. Yes.
Calculated table, it only updates during the refresh.
That's correct.
Right?
Yeah.
And so if we say that business intelligence, you've got 80% is all the routine queries, 20% is the more unique. You would want to use the summarized columns to create that table to answer the 80% of what people normally want, like color, gender, etc.
Yeah.
And then you would use other queries to query the whole table for the unique 20%.
Yes.
Okay.
Yeah. So one of the takeaway from this is this is really for large models. Is if your like a detailed table is too big, you can leave it as DirectQuery. So the data is not imported, right? So now you know that we have a composite model. So for the composite model, you can have a small table, aggregated table that can answer 80% of your queries, and that will be fast. And then for the large table, it's only used for the remaining, or sometimes you only use it for drill to detail operation. You don't even need to do any aggregation. Typically, it's basically the fast one, pick up all the filters needed, and then you do a drill through operation, and it will drill to the detail using the DirectQuery table. Then you can bring in the detailed record. At that time, hopefully you have picked up all the necessary filters, so you narrow it down to a small set of rows to be returned. Yeah.
And that's using managed aggregates, not summarized columns, right?
You can definitely use aggregate. As I said, today aggregate has some limitations, and if that for whatever reason it didn't work out for you, that this is the manual way, and the manual way is always there.
Can I ask you a question about the recent feature that came out, query caching? I flipped it on a data set and I looked at the performance and it seemed to be much happier, but is that part of the DAX engine or is that just in the Power BI service?
It's just in the service.
So just caching the display?
Yeah, yes, it's just caching the display. Yeah, it's just in the service.
Okay, thanks.
I think we have only 10 minutes left, so I just open that for everybody to ask questions. I'll stay behind as long as the building is open as well.
We'll be here all night.
I had a question about your Treatas example. When you did the summarize columns, would you physically render that table, or in practice would you actually just leave that inside your measure as a virtual table?
For performance, of course, you want to materialize.
Oh, you materialize.
Yes, yes. For performance. The reason you want to do measure is you want that thing to be filtered. Right? Calculated tables are not filtered by visuals. So this is another misconception for beginners. I hope most people here no longer are confused by that. Calculated tables and the calculated columns belong to the data layer. At the data layer, there's no filters, no visual filters. Okay? So there's a visual layer, there's a data layer. So calculated column and the table belong to the data layer today. Only measures are in the visual layer. Visual layer means that it will pick up the filters on your report because your filters are all on the visual layer. Right? So calculate table and calculate column are never affected by any filters on your report because they exist before your report exists. They are materialized.
Hey, quick question. So when you did that summarized table, is it better to do it via DAX, or would I have been better off doing that in a query?
I would do it in a query because today, when you do it in DAX, there's some dependency issue when you try to create a relationship back to the original columns.
So
I would do it using the Power Query.
Okay.
It's just like it's convenient for me to do it.
Right. Yeah. Got it.
So the best definition I've heard so far for row context is what it's not. So what I've heard is it's similar to the current row, but it's not the current row. How does row context behave? What is it? Is it just a set of tables? Is it sort of a...
Row context is really nothing but the iteration. It's for people who know the for loop in programming language. It's just like when you have a for loop, then what's the current row? So row context is really very similar to the traditional programming for people who have done SQL, for example. When you've done SQL, or the intuitive way to understand the row context is if I create a calculated column. So think about this. Row context originally is for calculated column and the iteration. That's it. That's all there is. Okay? And the measures is for picking up filters. So so measures is a filters. When measure is invoked, there's no row context. Okay? All rows become filters. So they're only filters when measure started. The row context is when you have an iteration function, or have a more like a straightforward way is, let's say in my customer table, oh no, I have to go to my data view. In my customer table, and let's say I originally only has 3 columns, the first name, middle name, and the last name. But you saw I produced a report using full name. That's using a DAX expression just to concatenate the 3 columns together. Where's my full name? It's on the right side. Yeah, it's here. And so here it says if middle name is blank, I would just concatenate the first name and the last name. Otherwise, all 3 names are concatenated together. So this is the so-called row context. There's really nothing to it. So row context is easiest to understand when you create a calculated column, right? When you create a calculated column, I said, okay, my this row is going to be based on all the values to my left. So those are 3 columns to my left. So this is my current row. I'm evaluating in my current row.
So if I'm teaching it to somebody and I say, think of it as the current row,
Yeah.
is that sufficient? Am I leading them down the wrong path? And that's just
right.
fantastic.
So yeah, and the iteration is the same thing. We have a filter function. It's basically filtered on the table row by row, and for each row, that's a row context, and then you evaluate the predicate.
I just had a quick question on the Vertipack engine. I seem to remember, and maybe this is wrong, that Microsoft purchased the Vertipack engine from somebody and then made it their own, or I heard you mention earlier today it was written from the ground up.
We actually were negotiating with ClickTech, and but the deal never went through, and Microsoft said, okay, we just do ourselves, and we start from scratch, Vertipack engine. If anything, SQL Server relational database later on, they introduced the column store index. They actually copied our Vertipack engine code for their column store index. So if you say Microsoft borrowed Vertipack, some code for Vertipack, other teams borrowed the Vertipack code. But the Vertipack code was written from scratch by the BI team.
And the first place it showed up was in Excel?
Yeah, Power Pivot.
And then it went to SSAS.
Yes, Power Pivot, SSAS, and actually I think the column store index comes around the same time as SSAS, tabular, and then yeah.
Just to go back to your first point in the whole thing, that filters are tables, right?
Yeah.
I think most people think, even if they don't write SQL, they tend to think if I choose a color, it's kind of like a where clause.
Yes.
Where color is red.
Yes.
And that's really completely different than what's happening here, or is that, I'm trying to help people.
In the vast majority of the cases, they are equivalent. Because when I say there are filters, semi-join operation in the most simple cases is equivalent to where that column. So if I'm semi-join with a single column and a single row, then it's completely equivalent to where that column equals the value in that row. Whereas a multiple row is completely equivalent to where that column in the list of values in that row. So semantically, they are completely equivalent. The reason I say everything's a filter because we can handle non-trivial filters, and also we have a uniform way. So as you said, the DAX is very consistent under the hood. So all the filters are consistent as well. It's just like we use a different optimization technique to convert them into where clause.
Is it, I haven't thought it through logically completely. Is it unreasonable to ask for a filtering measure?
What do you mean by measure? I always filter.
Well, no, what I mean is create a measure that does not return a value. It returns a data set, which is then used as a filter somewhere else.
So you want a table value to measure?
Yeah.
Okay. We actually already built that in the engine. It's just the way again, program managers never found a use for it. So we never exposed this through user interface. We actually have table value measures already built into the AS.
So we just have to say we want that?
Yes.
You want it.
The reason I haven't retired yet, I know there's students.
Is there some shortcut impediment to that? I mean, if we
no impediment. It's just like you have to come with basically in the end. It's very hard to sell an engine feature. It's much easier to sell like a touchable, visible, like a business feature, right? So like exactly what business requirement you have.
You said this is the biggest user group, right? We can throw that.
But right now the top votes are in the thousands. So if everybody votes here, still
Well, most people don't know what to ask for.
Yeah, that's the whole thing. People don't ask about engine features. Right? They didn't even realize that that's actually, for example, if I don't tell you that convert blank to zero is a visual feature, everybody thinks that's a DAX feature. That's not a DAX feature. Right? Many people think that's a DAX feature.
I found that vote, by the way. It's got 5 votes so far.
I think we could all be tracked.
So yeah, there are a lot of those like platform level features people didn't realize it's there. For example, there's another very common feature. I tell you, engine has this for a year now, and nobody asked for it. For example, grouping, right? Today, if I create a grouping, let's say I want to group products by the sales, right? By different levels of sales, right? But I want to bucketize the products into different buckets, right? This is very common, right? So it's also very common for me to say I want these buckets to change based on the filters in my report, right? Wouldn't that be a very natural thing? Today, if you try to do grouping, because it's a calculated column, it belongs to the data layer. Therefore, it doesn't see any of the visual filters. So today, your buckets are fixed, cannot change. But many people say, I want it to change based on the filter. I want to say, if I select a year, I want to bucketize my product based on the high-low sales in this year instead of across all years, right? So we know this is a desirable feature. So we build a feature called like a virtual columns. What it means is it's a column, it's a calculated column, but it's evaluated just like a measures. It's a query time, it's a visual time, instead of materialized in the underlying table, right? So we have this feature, but nobody asked for it because nobody knows this is an engine feature, right? Nobody, and also this is an engine feature that has many different business applications, right? So it's one feature that can have a completely different set of usage scenarios, and so this kind of thing people don't vote for. People tend to vote for the immediate tangible things.
Can you just send us a list of things we should vote for?
Yeah, sending out that last one. So Chris found where to vote, and I will send it out to our email list.
And okay, so if you if you want to vote for one feature, I want you to vote for this feature. Actually, if I tell you, you all agree you want to vote for this feature. I already told the previous audience. Today, if I have a report like this, I want to do a running total. Let's say I have a today, if I have a small report across different product subcategories, I have the customer count, right? So once I get the customer count, I want to say, can you show me a running total, right? How many people know how to write this measure? A couple, right? It shouldn't be like 90% of people know how to do it, right? This is like a very basic thing. How do you do a running total? So this is the thing I want you to vote first before anything else. This is what I call the visual calculation. Unfortunately, I don't know what's the correct term. Again, it's a fundamental feature. What it means is that this is one thing today, in my opinion, that's too hard to do in DAX. And in the 80% of the case, all right, we can do some really nice features in the 20% of the case, but we are using the same technology to apply to the 80% of the case, which is too hard for average users. So what's this? Oh, I have to stay. I'm tethered to the podium. I'm not allowed to leave this, and so what I mean is. Today, one of the hardest things in Power BI is if you have a measure that calculates some values, and then you want to calculate another set of values by scanning these values that you just calculated, that's hard. The reason it's hard is all the measures are independent of each other. So the new measures you add to the report is completely oblivious to the existing measures. So that's why it's hard. So those measure calculations are hard to write. So I can write it for you here. So you have to write a report. Basically, you have to write a DAX measure saying if no, this is the distinct count. I wanted the count one. This is the count. No, this count. So we basically says I want to calculate the customer count by going over all the product subcategories where the product subcategory is less than or equal to the current product category. So I have to write this quite a complex DAX expression to achieve a simple running sum. So sometimes the performance is even bad. And one time I made the joke say it's faster for you to export this to Excel and do the running total in Excel than to actually run it. And so if I drag that one here, running total.
How do you imagine that feature would be, like a quick measure or a drop down on the?
It will most likely, imagine, I will make it a UI thing, right? So on the UI, I can say, right mouse click and say, I want to do a running total of this one. And give me a running total of this one, right? And so you can now I get a running total, right? And again, it's easier to see in a, if I give a conditional formatting of data bars, so you can see I'm not cheating. So it is a running total, right? But what's the benefit of the measure-based approach? And is this running total makes sense because I'm doing a customer count. So I'm saying how many customers bought different products, right? This is what I did, and then so it makes sense to add up the running total, right? So the total number of customers. But I also have another measure here saying distinct customers, which is the distinct number, the number of distinct customers bought the different products. In this case, if I do the same running total, it will be wrong. If I do a sum, if I do a visual total, it will be wrong. So if I exported this to Excel and do a running total and present my running total of distinct products and send to your manager, that's a wrong number. Why is that a wrong number? Because it's no longer distinct. The same customer can buy different products. So if I'm adding the number up, I will be double counting them or triple counting them, depending on how many different products they bought, right? So this is a build. That's why I said we solved the 20% case really well. The 20% case is exactly the same formula. I use exactly the same formula, except when I calculate, instead of calculating the count, I'm calculating the distinct count. Other than that, the base measure, I changed the base measure from customer count to customer distinct count. The rest of the formula look identical. And then when I add the same formula here, distinct count, I put it next to the distinct, the base distinct count, and then let me add some conditional formatting. You can see it's still a running total, but it's no longer a simple sum. So DAX will calculate the correct distinct count for you. That's the power part. So we are eliminating duplicates automatically for you. So today we're using the same technique to do the count and the distinct count. So as I said, we solved the 20% case really well. But unfortunately, it's very hard for people to figure out this formula. So if you want to vote for one feature, I want to vote for this feature. It's basically make it easy for you to do this kind of a visual level calculation, like a running total, moving average, or year over year, like a year over year. If you only have a single column a year, how do I take this value compared to the previous value? Those type of things, right? So basically, you want to scan values you calculated currently on your report. You can no longer based on the same row. You have to go to the previous rows or below rows. So you have to go up and down to calculate the value. So this will be a useful feature to vote first.
Yeah, I think I found it says calculated columns and visual row has one more.
That's huge.
Yeah. Yeah.
Jeffrey, did you sort this? Did you invert the sort order? Is that break function?
If I that's another one. When you say break, it will not be the same. Yes, that's very true.
Yeah. Which is not to say it's broken.
No, it depends on what you mean. So the good thing about it, this DAX measure is based on based on a particular sort order. It's not based on the visual sort order. It's based on the sort order encoded in my filter function, which is I'm using the less than or equal to, which is implying an alphabetical sort, and I'm getting the ones sorted before you. Okay, so I'm calculating that one based on a particular sort order coded into DAX, regardless of the visual sort. So that's another difference, right? But there's a beauty to it too. Then that means that I can independently evaluate that measure even without all these values. I don't need any of those values. I can put it in a card, and then I can say what's the running total, And then I can filter it by different product subcategories, and then it will still work. So it will work by itself. So that's the beauty of a measure-based approach. Measure-based approach means I don't depend on the presence of the base data for me to calculate. I can calculate in any visual, anywhere, with or without the base data. So that's the beauty. But when you do have those base data, you still have to do it that way. That's the hard part.
So you reverse order of the product on that table.
So you can say I can still, so even though I drag that measure into its own visual, it can still produce the correct result. Because I don't need the presence of base values. All the measures are calculated independently.
So change the sort order
It's changed the sort order will not change the value, but it may not look like a running sum to you, depending on what you mean by it. If your running total means the visual order running total, then that's another reason why you want to vote for that feature. Because that feature will produce the visual one instead of the hard coding.
Somebody using this has to know
the order.
Yes.
So this really are not good measures. That's why I say those should be visual calculations, because a measure should be independent of what columns are on this visual and what order is sorted by it, right? So the measure should be free, like drag into anywhere. But this particular calculation is truly like dependent on a particular layout of a report. That's not a true measure anymore.
All right, well, I think we'd be here all night. Yeah, I don't try and wrap this up somehow. Does anybody have the card with them that was being passed around? Anybody have the card? Nobody?
Where there was a card.
There was a card being passed around.
No!
Is it right there?
Stopped.
It got stopped? All right.
Yeah.
Well. Cool.
Everybody.
So Jeff, we got you a card, we got you a gift, of course.
Thank you.
It's on behalf of everybody, user group. So
I'll give it to
and
Ray.
those that had it. So it's for you. And we got you a $50 gift card. Sorry, guy. Yeah.
Rachel got you a flower.